Hi friends, it's John. You are on the JRB Tree Climbing channel. JRB Tree Climbing is also the name of my website. It's the name of my Facebook group and is the name of my Patreon should you wish to support me in my journey with safe climbing. Over the last year, we have been working on variations of the JRB Ascender hitch, a novel friction hitch that can be used in a variety of climbing and rigging applications, and I'm settling on my preferred variants. I recently released a video for this one here, tied in 7mm on 10 on the left. This is the 523 JRB Ascender tied in soft bridge mode, and this is the hitch I use most frequently in my JRB double rope climbing system. It has this nice feature where you can expose one loop. That's how I climb with it in JRB, or you can expose a second loop, and then you get this easy one-handed operation where we can advance the friction hitch, unlike any other friction hitch I am aware of. And for certain applications, such as a tether connection, that's really nice. With no metal, I can advance or adjust the exact position of the hitch. And it gives me a little room here for other scenarios. You go watch my video on recovery after loss of footing. It's nice to have a little room here if you want to attach a Munter friction hitch if you ever lose your footing. So we're going to put that aside and we're going to take a look at the compact JRB Ascender tied in the non-jamming variant. So the anti-jam characteristics of this on the left are adequate for me. I never have any problem with jamming under normal climbing conditions. If we subject the friction hitch to an excessive load, then yeah, it might get jammed up, but that's not a normal operation for any kind of climbing. Friction hitches should never be used to absorb a fall to begin with. We can tie this in an ultra compact variant. I previously released variant 1. This is the second variation and my preferred one. What we get here is a really compact friction hitch, which still has, let me put a carabiner on there so my fingers aren't in your way, but we can still get this really smooth operation because either a carabiner or a rappel ring is guiding the rope. It's extremely smooth to advance compared to this. There's going to be more friction. There's going to be more friction on this, especially after a load. So this is smoother. It's very compact. And I use this in certain applications, such as anytime I need it to be optimally compact, anytime that I need to manually advance the hitch. All right, so what do I mean? Let's say I'm doing a hitch climbing where the rope is pressed really close to the tree trunk and my body weight is on it. I can't really get my hands back there safely to advance it. Well, you can simply pull on the ears, on the tag ends here, and advance it this way. So when I want to manually advance it without getting my hands around behind it, it's optimal for that. It's also useful in applications which require automatic tending. So if you're familiar with arborists will climb trees using a moving rope system, they call it a hitch climber pulley, where a pulley is placed below the friction hitch to help advance it or automatically tend it. Well, we can rig those kinds of systems here without a pulley at all because the friction hitch itself will simply tend. There's no need for a pulley. We're able to get it optimally compact. And the other application, and these are still evolving, here on the left, I've built a mechanical advantage system using two JRB Ascenders in the compact non-jamming variant. So what's going on over here? Here I've got a friction hitch tied to a carabiner. You follow that line down here. I've got a load. Here's a minor weight being placed on this, coming back up through another hitch. And what I'm able to do is build a progress capture and mechanical advantage system. So when I pull on this line, I will be diverting the tension on this line, and I get a mechanical advantage system with progress capture. I'm lowering the weight, now I'm raising the weight. And this operates really similar to a ratchet strap, for example, a cam buckle strap. And of course, without the mechanical devices, except for either a carabiner or a rappel ring. I actually like a rappel ring in this application, and we will be rebuilding it. So I'm just giving you some idea as to the possibilities for this friction hitch. And if you're familiar with RAD's SRT climbing, you can build an SRT climbing system using this. And in that configuration where your body weight is actually on the bottom and you are pulling here, it becomes a 3-to-1 mechanical advantage system. So there are all kinds of possibilities for this in different applications. We just need to understand how to tie the hitch and how to rig it. And that's what we'll be doing in this video. So give me a second to clean all this up, and we're going to start and show you how to tie it. Okay, so let's learn how to tie this. The jrbtreeclimbing.com website has a page called length specifications, and on that page you will find a table of information that prescribes that for an 8mm rope and for a 6mm cord, the minimum length of cord I can use to fashion this is approximately 60 inches or 152 centimeters, and that's what I have here in the green. It also prescribes that my initial working end, or working end 1, which is here on the right, should be about 37 inches or 94 centimeters. And so I have that point measured and pinched with my left hand, and I'll place it over the front of the rope. And I will make 2 coils in an upward fashion, and this is what we call the Z chirality. If you overlaid the letter Z, the center segment of that letter Z would be in alignment with these coils. That's what we call the Z chirality or right-handed chirality. And it's just easier for a right-hander to tie in that fashion. I'll then drop this down over the front. And now I will take that working end, I'm going to drop it down in the opposite direction of the point of this nail. So again, I'm tying this in the right-handed or Z chirality. Of course, it can be tied in the opposite chirality. There just is no need to do so for this compact variant. I'll just tie it in whatever manner is the easiest. I'm taking that line out the back. It's not coming out the front. And this comprises the lower stage of the JRB ascender. If you've watched prior videos, this is all common to all variants of the hitch. It's the bottom, completed bottom stage. I now take the working end out the back and continuing, very important to continue in that same right-handed or Z chirality from left to right. I'll take it and make 5 coils in an upward fashion. 1, 2, 3, 4, 5. I'm not going to take any time to get that too pretty because I'll immediately transition into the 2. I'll take the working end and I'm going to put it up through the first and second coils. You don't need the nail to tie the knot. I'm just using that as a visual aid. And I like to get this nice and snug when I'm tying the compact variant. So what do I mean? I'm pulling on this, you can see, but I can also spin. See how I spin this rope, this cord? Get as much slack out of that as you can. Don't worry about it being too tight or jammed up. Okay, now we have an almost completed standard JRB ascender. All we need to do is take that working end, and again, I'm going to, in the reverse direction of this nail, it's going to come through this bottom stage from the point to the head. It's going to trace that in this direction. Let's do that. Here's the working end. Bring it through this bar, and I've tied it kind of compact, kind of tight, a little bit jammed, but that's okay. I want to err on the side of making it too tight rather than too loose, and I'll show you why. So that comprises a completed 523 JRB ascender. But we need to transform this into the compact and non-jamming variant. And here's how we're going to do that. So the first point is, instead of using a carabiner, I'm going to use a rappel ring for this. And I will place it on the rope. Okay, so I'm going up. So there it is. And in what orientation do we like this? We want the body of the carabiner or the rappel ring to be on the other side of the rope. And now we're going to secure it. I continue. Okay, so this was the working end coming out of the right. We are now going to make that working end actually stationary. We're going to take the original standing end and work with it. I will go around the back and through the carabiner or ring. And now I will be inserting this line. In what location? In this location. Right up above, I will be going, of the three in the 523, I will be separating the top and the bottom two and inserting my nail there. That's the location where I am going to insert the original standing end, now the working end. Okay, great. Now I can let go of the ring, it'll stay in place. That line comes out the back, goes through the ring on the other side, and now it will replace this. I'm going to back this out, and in the gap it formed, bring this. So, and look, my length got really lucky here. These are really close together. So to complete this, we form a flat overhand bend here, but we want to get this thing as close as possible to being tuned before we do so. And here's how I do that. It's impossible to tie a flat overhand bend with no slack. There's going to be some slack. And if we get this thing adequately set, we can get it pretty darn close to perfect with the initial tie and minimize the need for tuning. How do I do that? Well, the first point is I want to get all the slack out of it I can. So I spin this upper helix and I grab this descending strand and I pull on it. I just try to get that as tight as I can. It's all jammed up. It's all jammed up. Same here. Get that adequately snug. So I've got this as tight as it would be very difficult to move in this position, but that's okay because a little slack will creep in. And now I will tie a flat overhand bend using these two strands. A flat overhand bend is simply an overhand knot with two strands of rope. So being careful not to introduce any spin, I put my thumb under those two strands, around my thumb, and now replacing my thumb, I will bring those two strands through. I'm forming an overhand knot with two strands. And I'm going to kind of walk that and spin that as close as possible to the assembly. I don't want to have any extra slack. And when I get that, see there's no gap here. No gap. I got it pretty nice and tight. When I get it there, then I'll pull on one strand and I'll put on the other strand to get it relatively set. And now I will test it. I'm gonna pull on that, and it kind of settles out. You can see it's expanded a little bit. and it feels a little bit tight, but I haven't loaded that with my body weight or anything. And it turns out that I can get these set perfectly the very first time and not need to retune them. And this is how I do so. It's always better to have it feel a little bit tight than a little bit loose. Now we're going to tie another one, and I'll intentionally make that one a little bit loose, but this one is tied perfectly. And so now I can go ahead and I'm going to put a backup flat overhand bend here. I can't tell you that this is absolutely necessary, but I do believe that you know, the flat overhand bend is relatively a weak bend, and so I always like to back it up, especially for life safety applications. So I'm just going to make another overhand knot here, and you can see I'm quickly consuming all of my 60 inches of the original cord. I always put this one on after I've tuned it. So there we've got the completed hitch. Okay, great. Now let's tie another one. We're going to repeat that, and I'm going to make this one above, and for strategic reasons I'll move that one down out of place. And I will, everything is exactly the same. Excuse me for referring to my overhead yardstick, and I have that same working end of approximately 37 inches or 94 centimeters, and I'm going to repeat the process. And I'll do it again at a reasonable pace. This time I won't use the nail. I go upward 2 coils, down around the back, and I'll drop it down through these 2 strands and out the back. How tight? Well, just snug. It stays in place. Great. Now, again, remembering that I'm working in the Z or right-handed chirality, I'll bring it back to my left side and start with 1, 2, 3, 4, 5 coils, and then up through 2. That's the 5 and 5, 2, 3, and I'll bring it up through 2. Dress that out a little bit. It's snug but not tight. And now I will drop it down and through the lower stage. Okay, so I'm going to intentionally leave this one a little bit sloppy. Like, I know there's too much slack in this for it to hold adequately. And we're going to go ahead and finish the hitch and show you how we might tune it. Okay, so how do we do that? This time I'll use a carabiner. Goes through that same location, out the back, grabs the carabiner, and now replaces this strand. Replaces this strand. Okay, so I've built it. Again, I know there's a little too much slack in there. Let me go ahead and just form an overhand, flat overhand bend here. And maybe I was also a little sloppy. It could have been any of these steps that I was a little sloppy on, like I'm leaving a good 1/2 inch or centimeter of slack here. So yeah, I've tied it, but look, it doesn't hold. it doesn't hold. Yeah, sure, you might be able to get it to hold by holding that, but it's got way too much slack in it. So how do we dress that out? Okay, so the first point is I'm going to pull on now that I've got it. I'm going to pull on this. And get as much slack out as possible. In this case, I'll untie my hitch. I'm going to tug on this end. I'm going to tug on this end. I got that all bound up and tight. It won't even move, but that's okay. Some slack will creep back in when I install the flat overhand. Important when we're putting in the flat overhand that we don't have any overlap or crossing points inside the bend. It's very neat. There's no twists, no overlaps. And now, again, I'm just hammering on that with my right hand, and it's perfect. It's set just perfect. Okay, now there's a reason I did things in this order. I'm going to remove this carabiner, and notice that when you use a carabiner instead of a rappel ring, if you were to leave this pre-tied and jostle around in your bag, well, you know, things can happen, you know, to this bottom stage, and it could get confusing where to insert your carabiner. And so for that reason, I like leaving the carabiner on the rope if you're using it with a carabiner, or better yet, using a rappel ring, which obviously can't be removed. So let's untie this and just back this off. Just back this off to the end of the last portion. I don't want to tie it completely all over again. Now let's remember, down here lower on the line, I've got a completed JRB ascender, and the ring went through the line. I'm going to take that and I'm going to fold it. Let's back off a little bit here. I'm going to fold it upward. So here it is. Bring that down, and I'm just bringing it towards the camera, folding it upward. I'm going to take that rappel ring and I'm going to use it to tie onto the bottom of this hitch. So I'm building the mechanical advantage system. I'm going to bring this through here. Around the back, up through the rappel ring, and then replace this line. Now, it will help you to look back at some of the other videos on the playlist for the JRB ascender. You might pick up some tricks. I hope I'm not moving too quickly, but most of the steps are common to all of the variants. Now, let's get this adequately snug. Okay, got it nice and tight. I'll install my overhand bend, my flat overhand bend. I've learned to kind of spin this, and that helps walk it in to minimize the, and knowing that I've done a good job, I'll go ahead and install the backup right away. I try to get the backup as close as I can to the primary. So 60 inches went pretty quickly, leaving tails of only this size. Well, so what have I created here? I've created my mechanical advantage system. I'm going to get out of view here. I'm going to attach that weight. I'm going to attach it to the bottom of my rope, and we're going to change our zoom level a little bit. I'm going to pull on this, and watch closely let's zoom in and watch what's happening at this place in the hitch. So I'm raising that weight with a 2-to-1 mechanical advantage. Now, I'm not going to really get 2-to-1 with all this friction of you need to use pulleys if you really want to get close to a true 2-to-1. But I am getting mechanical advantage and really quick progress capture with very little setback. Let's move that up so you're actually watching the top of the weight. Watch how little setback. So I'm gonna go up, and now when I let go, boy, it hardly moves at all, right? This is really, really handy for a number of applications. Now, obviously, I wouldn't be able to lift this if it was an exorbitant amount of weight, but I can lower it right here. So again, you'll see me using this for attachment methods, for example, with a platform, but a lot of other applications I'm learning. Let's take a zoomed in look at the hitch for inspection purposes. 5 in 523 refers to the 5 coils on the upper stage, and they are tied in the expected position, that Z chirality with the upward slant from left to right, the order in which I tied it. 2 refers to that the coil as the load strain comes down off of that upper helix, that upper top coil, goes up through 2 strands on the link segment on the side. So that's 2. And 3 refers to how many bars are visible at the bottom. But we've got this great big bend in the way, and so we can't really tell. And so inspecting the bottom stage really just goes like this. The first point is that these strands, as they come together and form the bend, well, they tend to occupy the bottom and not the center of the 3. But if you count it as a strand, there's 3 strands going through that bottom stage. So that's the 5, the 2, and the 3. Now, honestly, I actually don't ever inspect the back of the hitch. It's kind of ugly, and so I really generally don't do that, but we'll pause there and give you a 360-degree view of the hitch. I'd like to point out that when I tied it with the rappel ring, you heard me say it makes sense to put that in the back because you get the easiest one-handed tending. But when I tied it with the carabiner, I had the carabiner in front. And with a carabiner, it's easy to change the position. So let's go ahead and put the carabiner in front. We can still get one-handed tending operation here, but it's not quite as smooth. The hitch folds just a little bit. I mean, it works, but I tend to prefer it in the back when I want the auto tending, and in the front when I'm using it just for rigging, because it tends to just hang down a little bit more straight and divert the rope less. And the last point I want to make, and this is true not only of this friction hitch, but just about any friction hitch that has a helix at the top, is that if we find ourselves in a climbing situation and the hitch is not holding, like we think we got it set correctly, but then we're in the middle of a climb and it starts to slide on us, the first point is, we don't panic. We can get that to hold. 9 times out of 10, all we need to do is, if it's moving, we simply, as we're placing load, we simply pinch that top helix and just give it a chance to hold. But we know that it's not grabbing as quickly as we'd like it to. And so that's a good time to simply rappel down to the bottom of the tree. And if you need to retune your hitch, no matter what hitch it is, that's the best place to do it, never in the canopy. And again, with this hitch, we're tuning it by pulling as much slack as we can out this way, untying and retying our bends. So Basically, I've got this whole journey with the JRB Ascender boiled down to two variants: the 523 JRB Ascender in soft bridge mode with either 1 or 2 loops exposed. Separate tying video for that. And this, the JRB Ascender in its compact and non-jamming variant with a host of different applications. And first up for this will be improvements to the JRB hitch climbing method. Thank you very much for your support, and I look forward to showing you this in action.